Hello guys out there, welcome to our Google class. Today we are going to have the chemistry lesson. We are going to look at chlorine and its compounds with me, teacher Twaha, and teacher Evans on the camera. We are going to look at chlorine as our subtopic. Objectives for our lesson include these three. You should be able to name the compounds used to prepare chlorine in the laboratory. Number 2, you should be able to list the materials we use when preparing chlorine in the laboratory. Number 3, you should be able to describe laboratory preparation of chlorine, indicating the conditions necessary, the drying agent, the method of gas collection. Let us begin with objective number 1, the compounds used. We use potassium permanganate and concentrated hydrochloric acid. 2, we can use manganese oxide and concentrated hydrochloric acid. Objective number 2, the materials used in preparation of chlorine. We use the isopropyl flask. It can be flat bottom flask like this one, wash bottle, delivery tubes, and the gas jar. Preparation of chlorine using potassium permanganate and hydrochloric acid. Hydrochloric acid is put in the thistle funnel, and potassium permanganate crystals are put in a flat bottomed flask. When you open the tap, hydrochloric acid drops into the flask and reacts with potassium permanganate to produce chlorine gas. This reaction does not require heating because potassium permanganate is a strong oxidizing agent. Oxidation means removal of hydrogen. Potassium permanganate removes hydrogen from hydrochloric acid and we get chlorine gas. The chlorine gas produced is passed through water to remove hydrogen chloride fumes. Concentrated hydrochloric acid always forms hydrogen chloride fumes, which we remove by absorbing the fumes in water. Chlorine gas is slightly soluble in water, but hydrogen chloride fumes are more soluble in water than chlorine gas. Some of the chlorine gas will dissolve here, but most of it will continue into the next wash bottle containing concentrated sulfuric acid. Concentrated sulfuric acid dries chlorine gas by absorbing moisture from the chlorine. The dry chlorine gas, collect it using downward delivery method because the gas is denser than air. Downward delivery method is also referred to as upward displacement of air, where the chlorine gas comes down to the bottom and then the air is pushed up. That's why it's called upward displacement of air. If you don't use potassium manganate 7 and the concentrated hydrochloric acid, you can use concentrated hydrochloric acid and manganese oxide. We use the same apparatus and the procedures are similar. There is one difference in these two preparations. When we use manganese oxide, carry out heating because manganese oxide is a weak oxidizing agent. It has less power, less energy of removing hydrogen from hydrochloric acid. Therefore, we have to carry out heating in order for manganese oxide to oxidize hydrochloric acid. When we are using manganese oxide, we use a round bottom flask because there is heating. When we are using potassium permanganate, we use flat bottom flask because there is no heat. The conditions for the reaction is that in the first preparation, where we are using potassium manganate 7, the reaction occurs at room temperature. That's condition 1. Condition number 2, hydrochloric acid must be concentrated. In preparation number 2, where we are using manganese oxide, condition number 1, heating of the mixture is required. And condition number 2, hydrochloric acid must be concentrated. Basically, these are the two methods by which we prepare chlorine in the laboratory. If you have any comment, please put it down there in our comment section. We shall be able to answer some or most of your questions as they will be asked.